want you to imagine you're working for a restaurant and placing an order for 65 packages of hamburger buns. Each package contains 14 buns. You need enough buns for 1,000 burgers for the week. Did you purchase enough? How could you mentally solve 65 groups of 14 or 65 times 14? Go on, think about it. Pause the video if you need more time. Don't feel rushed. Remember, being fast isn't what we're after. Did you maybe solve it like this? First solving for 65 times 10, and then 65 times 4, and then adding them together? Or maybe you solved it by breaking apart the 65 into 10s and 1s. Hi, I'm Sarah Porcenelik, and today we're discussing the third grade standard NSO.1.2, which calls for students to compose and decompose 4-digit numbers in multiple ways. The odds are to solve 65 times 14 mentally, you manipulated the numbers in some way that made it easier for you to solve. This involved you decomposing and then composing numbers. Teaching students to be flexible with numbers and know how to decompose and compose numbers is a critical foundation for learning how to multiply and divide in subsequent grade levels. When teaching this standard, it's important for students to truly understand the numbers that they are working with. For example, stating that 4,268 can be represented as 4,000s, 200s, 610s, and 8 1s may not be a complete picture of students' understanding of how to decompose numbers. They may have simply memorized the place value of the various digits. Using questioning strategies while teaching this standard and others can help you get to the root of what students really know. Research tells us that teachers tend to ask questions that call for one correct response or lead them all down the same pathway to solve. The types of questions that push students to think critically can be considered divergent questions. Let's look at an example and what questions you might ask to push students to think critically. Let's say you work at a pencil factory this time. You place pencils in boxes of either 100 or 10. You have 4,271 pencils to box up. How many boxes of 100 can you make? How many boxes of 10 can you make? Let's say students have come to the answer of 42 boxes of 100 and 7 boxes of 10, with some left over. How can we extend student thinking from here? Here are some divergent questions you may ask students. Are there any additional ways to box up the pencils? Let's suppose you can only make 32 boxes of 100. How does that change your answer? How can you prove your answer? Either by explaining and justifying, drawing a picture, or using a manipulative of some sort. Let's say you want to box the pencils up and have exactly 30 boxes. How could you box them? Why might you want to box the pencils up differently? Now, that last question you might be wondering a bit about. Why would we ask students that question? Won't be tested. It's really not part of the standard. Mathematics in the real world is usually not carried out for an empty purpose. We use mathematics in the real world to help make our lives easier, solve problems, and to plan. So asking students why a company might want to package pencils differently can help them to understand why decomposing numbers is useful in the real world. Students may surprise you in how they connect mathematics to the real world if you just ask them. This conversation can also lead to the following questions to push students into thinking about how this standard relates to other standards. Take this example. A bakery made 2,316 muffins today. They put the muffins into containers of tens or one. What is the fewest number of containers that they can fill? First, students must understand that they can decompose 2,310 into 230 boxes of 10 and 6 boxes of 1. What if the bakery could put muffins into boxes of 100? What are the different ways that they could be packaged? This question would move students past the limits of the standard, but would allow them to continue to practice decomposing and composing numbers while pushing their critical thinking. Therefore, this would be an excellent task at the end of a unit or for small group instruction. Giving students physical manipulatives would probably be essential here, such as place value blocks. This standard can seem pretty easy at first for students to grasp. However, pushing students to critically think about composing and decomposing numbers is vital with this standard. Students can begin to have fun with all the different ways that they can play with numbers. Remember to ask questions which push them to think past a one-word answer or the same answer all the time. Take a look at the resource page that accompanies this video for more insights into questioning techniques. Until next time, thanks for listening.